All right, y'all, we're gonna go ahead and we're gonna build the exponential equation that goes through these data points. And in order to do so, the first thing that we need to do is find the rate in this exponential equation. So remember what we do is we look for the ratio in which we're multiplying each number by to get to the next one. So in order to do that, we just take the second term, 748.05, and we divide it by 1,000. And we continue to do this all the way down the list in order to find the rates. Now, as we do this, what I want you to really pay attention to is that in the X, in the Y column, so in the X columns, the gaps are between 1 and 5, which is essentially a gap of 4, and 5 and 7, which is a gap of 2, and 7 and 10, which is a gap of 3. Those gaps are changing, and as a result, as we do this division, or we write it out, our answers should come out to be a little different. So to help us out, I went ahead and put that information in already. And so you're going to see some of that information on the right hand side. So 748 over 1,000 is 0.748. The next one is 0.864. The next one after that is 0.804. And the next one after that is 0.6956. So let's say we'll just go 0.696. Now, the problem with this information is, hey, the rates are different. And in order to write an exponential equation, the rates all have to be exactly the same. So if we take a peek over here on the left, you're going to see that there is a gap of 4, there's a gap of 2, there's a gap of 3, and there's a gap of 5. And what that means is the rate has multiplied by itself 4 times in this one. The rate is multiplied by itself 2 times in this one. So we can actually take our current rates and just make them r to the 4th equals to r to the 2nd. The gap of 3 equals r cubed. The gap of 5 being r to the 5th. Now, how do we get rid and solve for just a basic rate for every single one unit is going to be what we need, because we need just r. So what we do is we put 1/4 in here. And then this is 2, so I put 1/2. This is 3, so I put 1/3. And then I put 1/5. And I just put those to the opposite or the reciprocal of that size gap. So let's go up to the first one, and let's just type a few of these in and just see what happens, okay? If I take 0.7408, and I put it to the 1/4 power, it gives me 0.927, okay? Let's go to the next one. If I take this 0.864 to the 1/2 power, to the 1/2 power, guess what? It gives me 0.92. Right, 0.92, 0.92. If I go to the next one and I put 0.8 to the 1/3 power, so 0.804 to the 1/3 power, guess what? It gives me the exact same answer. And then if I go to the last one, 0.696, and I go to the 1/5 power, and I go to the 1/5 power, it gives me 0.93, which is pretty close. Look at 0.929, 0.93. So that tells us automatically that the rate is going to be 0.929. Now, we still have to, since we are looking for an exponential equation, and remember an exponential equation is y equals a times b to the x. This is our rate. Okay, and we've figured that out. Now we need the initial. And that is when x is equal to 0. Well, we don't have x equals to 0. We have x equals to 1. And we have to remember that in this direction, we multiply by the rate. In this direction, in the opposite directions, or the inverse direction, we need to divide by the rate. So I'm going to go and take that 1,000 and I'm going to divide it by our rate of 0.929. And that should give us 1,076. So now we should have enough information in here to write our equation. Y equals 1,076.929 to the x power. We can come back into Desmos, and I've put those data points on there. Okay? And let's just check our answer. So let's put y equals 1,076 times our rate, which was 0.929 to the x power. And it goes through all of those data points. We've done this correct. We have to remember to account for the gaps in the x when we find the rate.